Let's talk about chunk size and chunk overlap. These are two concepts that we need to understand if we want to make a RAG application. Now, generally speaking, these two things, they can make your RAG application better. First, I want to tell you a quick problem with these RAG applications. I want to show you something. So we go here, of course, in Paint, and let's just say your document looks something like this. Let's just say that you have a PDF or a markdown text or whatever. Your markdown text will look something like this, so let's just say there are a few pages of text. Generally speaking, if we upload the entire PDF in our vector database, the LLM always sees the first part of a PDF relatively clear and also the second part of the PDF relatively clear, but the stuff in the middle, yeah, this stuff is not that great. So the LLM will not be that accurate with this stuff in the middle. But we have something that is called chunk size. We can feed the LLM small chunks, and then these chunks get embedded. If we embed the whole document at once, it is a high probability that the stuff from the middle ground is not perfectly accurate. But we have, of course, the chance to make chunks of this text. For example, a chunk could be something like this, then this, then this, and that. So we have, for example, 4 chunks, and every single chunk right now is separately embedded in this vector database, and then the LLM can always search these chunks. This is an important concept that we need to understand. And the next important concept is that we can not only make these chunks, we can also make chunk overlap. Let's, for example, say that we have 1,000 tokens right now in this chunk. So the LLM will search, for example, for dogs. And let's just say the LLM find a lot of dog chunks or a lot of dog tokens in this first chunk. And maybe also something down here. So the LLM can be a lot more efficient and only searches this first chunk and this third chunk and will not take a look at this chunk. If we don't split these, if we don't make these splits, the LLM will search the entire PDF and the output will not be that great. The output will most likely miss a few chunks from here. But of course we can make these chunks, and then the second thing is that we can make chunk overlaps. An overlap simply means that we can also take this right here. So the first chunk would be, for example, this entire chunk until down here, but as soon as the LLM searches the second chunk, it will also search in this middle ground once again. So if there are some tokens about dogs, right between these two chunks, the LLM can search these chunks a little bit more accurate. You know, every LLM has a token limit. And if the token limit is a little bit too small for our chunks, for example, for the whole PDF, the output will be really bad. Yes, the token limit gets bigger and bigger and bigger with better and better models, but still, chunking down these PDFs is important. And I want to give you some rules. If we go in a text, this would mean something like this. If I upload this whole text without chunking it down, the LLM will see most likely relatively clear what's in the last part of this text and also what's in the first part of this text. But if we chunk it down, for example, in 5, 6, 7 chunks, the LLM will always search one chunk, for example, until here, and then searches the second chunk, and the LLM can give us the most optimal tokens. And if we use chunk overlap, the LLM will also take a closer look twice at these chunks that are overlapping. This is an important concept that you need to understand. I want to give you some general rules. If we zoom in this text a little bit that I have written right now, it depends on the type. So of course it depends on what type you use. For example, if you have stories, you can use chunk sizes between 1,000 and 5,000 if the context window of the LLM is large enough. If you have a big model with 8,000 tokens context window or 250,000 token context window, 1,000 to 5,000 tokens as chunk size is completely fine. If on the other hand you have shorter texts, shorter stories, shorter PDFs, between 500 and 1000 is perfect. If you have on the other hand items with lists and links, 100 to 500 could be a little bit better. And then the chunk overlap, roughly 1 to 5% is perfect. This means if you have a chunk size of 1000 token, an overlap between 10 and 50 is perfect. And generally speaking, you should play a little bit with these. Just play a little bit with these as soon as you make your RAG applications, because we cannot say like this text you need 2500 and an overlap of just 20. You need to play a little bit. Every text is unique and you need to play a little bit. But generally speaking, lists, shorter chunk size, short stories, a little bit bigger chunk size, really long stories and books. Here you can use really large chunk sizes. Now some more words on pricing, accuracy, and the size of your chunks and the context window. A lot of people have found out that the newer models have the context window really big. Let's just assume that you have a lot of data. So let's assume this is nearly a whole book. And let's just say this whole book has, for example, 500,000 tokens. There are models out there, for example, from Google, that have 1 million tokens. Yes, this is really true. We have models from Google that have a token limit of 1 million. And then some people tell us that we can simply upload these whole documents as one chunk. So we do not need to chunk this down. And I have to tell you something. Even if the accuracy would be good, let me tell you it's not, but let's just assume that the accuracy would be good, because Google has really strong models here. Google has the needle in the haystack test. Basically, Google can find a lot of good information, even if this thing would be just one chunk. But then this thing comes around, the price. I want to tell you that if you upload gigantic chunks, if you upload, for example, chunks that have like 50,000 tokens in every single chunk, you have the problem that the pricing gets extremely high. Now, why is this? Because you throw up all these tokens and the LLM need to process all of these tokens. So basically, if you send a query, every time 50,000 tokens get searched here. So you send a query that is gigantically high. If you have, on the other hand, chunks that only have 5,000 tokens, maybe you search like in 2 or 3 of these chunks, and then you have only 10,000 tokens that you send to the LLM. And the query will be a lot cheaper. So basically, you need to find the right chunking size. It will be cheaper, it will be more accurate, even if the model would allow you to upload bigger chunks. So basically, as soon as you are here, as soon as you upload stuff in your vector database, make sure to use the right things here. Of course, you use your Pinecone vector database, this is fine. You use the default data loader, it's fine. And then as soon as you use the character text splitter, this thing gets important. Here you need to type in the right stuff. So please just use the right chunk size and the right chunk overlap. Generally speaking, you know how you should type this in. 5% as a rough estimate for overlap. If you have just some basic numbers, you can also make an overlap of 0, then it gets even cheaper. And the chunk size, like I do not like chunks that are bigger than 5,000 tokens at once, even if you have like bigger stories, because we can work cheaper if we don't have this too big. So if you work with data that has numbers and is also relatively short, just use really small chunk size and also really small to no overlap. And then your RAG application will work a lot cheaper. This makes a big difference, even if the accuracy would be also good enough with chunking sizes of 50,000, but this is like stupid. We do not want to pay bills that we don't have to pay. So you will be more accurate, cheaper, and also faster. Your RAG application is also faster if you do not have to send out 50,000 tokens in every query. So 1000 is a perfect mix between stories and shorter texts, but maybe it's not optimal if you have items with lists and links. If you use items with lists and links, just go a little bit down. Generally speaking, you always have just a word and then the price, and for that reason the chunk size should be small, so that the LLM looks at this small chunk and find your price with this item immediately. So of course the chunk size should be small, and also the overlap is not really that important. And that's basically every single thing that you need to know about chunk size and chunk overlap. This is the next big thing that you need to know if you want to make a perfect RAG application. So I think now you are perfectly ready to rock with your RAG application. In this video you have learned that you should use the chunk size and chunk overlap correctly. Long stories, long chunk size. Short stories, shorter chunk size. Lists with prices or something like that, really small chunk size. The overlap, use something between 1 to 5% of the chunk size and you are ready to rock.